Good afternoon. My name is Aditya Singh and my registration number is 20BC0322.
My name is Chandra Bishwas, registration number 20BEC0286.
My name is D. Satyapranay and my registration number is 20BEC0300. Now let's get into the hardware component of our project. The name of our project is Phonodet. Phonodet is basically an incoming and outgoing call detector. The main objective of this project is to design a circuit that could detect cell phones in use and notify us. This circuit does not detect the cell phones which are on standby mode, switched off, or on airplane mode. Now let's get into the components. These are the basic components that are used to make our project. We have a 100 microfarad capacitor, a red LED, a 1 kilo ohm resistor, a 100 kilo ohm resistor, two 2.2 mega ohm resistors, a CA3130 integrated circuit, 0.22 microfarad capacitor, 47 picofarad capacitor, BC548 NPN transistor, a 9 volt battery, and a 9 volt battery clipper. So let's get into the important components. These three are the most important components in our circuit. First of all, we have 0.22 microfarad capacitor. The transmission frequency of mobile phones ranges from 0.9 to 3 GHz. In our circuit, this capacitor will be used to detect the RF signals emitted by the mobile phones. This 0.22 microfarad capacitor is chosen because of its small value and its large surface area, which is easy to detect the energy from cell phones. This capacitor basically oscillates and produces current when it detects any RF frequency produced from the mobile phones. So it acts as a detector in our circuit. The next important component in our circuit is CA3130 integrated circuit. The CA3130 has 8 pins which goes as follows: 1, 2, 3, 4 and 5, 6, 7, 8. For this integrated circuit to work, pin 7 should be connected to VCC and pin 4 should be connected to ground. Here, pins 2 and 3 are the input pins and pin 6 is output pin. The current developed from 0.22 microfarad capacitor will be given as input to pin 2 and 3, and the amplified output will be coming through pin 6, which should be connected to the transistor. This component will basically act as an amplifier for our circuit. Finally, we have BC548 NPN transistor. The leftmost pin is the collector pin, the middle pin is the base pin, and the rightmost pin is the emitter pin. We know that a transistor will act as an open switch during forward bias and a closed switch during reverse bias. This biasing can be achieved by supplying the required amount of current to the base pin. For this, we will connect this base pin to the output pin, that is pin 6, to the CA3130 integrated circuit. When the required amount of current will reach the base pin, this can act as a closed switch. So this transistor basically acts as a switch in our circuit. Now let's get into the connections. We use a breadboard and a bunch of jumper wires to connect our circuit. This is the schematic of our circuit. We will be connecting all the components in this way. So our circuit is complete. Now we'll go to the output. Now let us verify our circuit. Here I have a phone and I'm gonna place a call, and as soon as I place the call the LED is blinking. It may not be clear. I'll try to show it precisely. Now I'll be trying this again. You can clearly see when the phone is on call the LED is blinking, and as soon as I cut the call the LED stops blinking. So it basically detects when the phone is on call. So I guess the circuit works. So this is our project Phonodet, which detects incoming and outgoing calls from a cell phone. We hope you like this project, and we would like to thank our family, our friends, and our teachers for supporting us while doing this project. Thank you.